This is the way your data center might look to your data. Why? Networks haven't kept up with the dramatic growth of data storage capacity and user demands on that data. Like this freeway, your networks and telecommunications services haven't kept up with the traffic, and that's as bad for your users as it is for these commuters. With a compound data growth rate of 30% per year, it's tough to keep up. Have your storage area networks and switches grown with your data? How about your Ethernet infrastructure? If so, each 1 gigabit connection 5 years ago would be 4 gigabit connections today, and each 2 gigabit fiber channel connection would be 8 gigabits today. If you haven't quadrupled your network bandwidth over the last 5 years, then you're in for a pretty slow commute. How do you manage all this growth without the expensive prospect of upgrading your storage network every single year? Mid-range storage systems have not only grown in capacity, but they've grown in functionality as well. We're going to explore the use of modern solid-state disks, referred to as SSD, as a way to increase performance without continually upgrading your network. This technique, augmenting large-scale disk storage with SSD in what's now known as hybrid storage, is a whole new commute. This is a SanDisk solid-state disk drive, an MLC flash memory storage device. First invented for cameras, early flash memory was poorly suited for data storage applications. It didn't store every bit reliably, an acceptable concession to their low price for camera and video applications. And each storage element in the SSD only takes about 1,000 write operations before it stops working. It wears out. This is why we don't see a lot of USB memory combined with high write applications, a problem I refer to as death by database. Beat it hard enough with a write-intensive computer application like a database and you've got one dead duck memory stick. This, on the other hand, is a third-generation SSD storage device commonly referred to as a brick. It's designed to fit into the same space as a spinning disk drive. This one, manufactured by Intel, features an enterprise version of SSD, an MLC-type solid-state disk with much more robust error correction and wear leveling features. It not only stores bits reliably, but it stores blocks of data in different locations to even out wear. If you have a data block error, rather than stop working like in the old days, the brick uses an extra standby block which is substituted for failed blocks, offering a limited self-healing capability. It also has about 10 times as much write-wear capacity, so in cases where you're not using more than about 30% write-to-read ratio, this could be a very acceptable and lightning-quick substitute for a spinning disk. Some data storage usage patterns are more suitable for SSD, and others, well, not so much. For instance, if you have to store backup or video data, or you're streaming data to storage continuously, SSD can do it, but it's simply too expensive compared to spinning disk to be practical. On the other hand, when you have highly randomized reads and writes, and mostly reads as I mentioned before, SSD is perfect. You see, SSDs have no moving parts. So unlike a disk drive, where you have to wait while the disk locates data in this place and that, the delay called latency slows things down. Latency is made up of two unavoidable limits to spinning disk performance: the rotational speed of the drive and the speed with which the read head can position itself over a particular track. These limits cause delays with every read or write request. SSDs have no such limits. SSDs store data reliably and they offer very fast read and write performance. So how do you properly integrate SSDs into your data center to take advantage of their capabilities? The obvious targets for SSD storage are readily identifiable and separate performance-constrained data sets. For example, database indexes. They contain predictable, high-demand data. And with the recent popularity of virtual server environments like VMware and Hyper-V, storing boot partitions and virtual machines on SSD gives your entire system much better performance. And in VDI, where you might have thousands of virtual displays running on laptops, tablets, and even on cell phones, performance is greatly enhanced with SSD. People have used SSD for these applications with great success for several years now. But there's a new way to use SSDs which is quietly revolutionizing data centers all over the country. One which not only gives you better performance, but makes it possible for you to easily adapt and tune your data storage with greater overall effect and at lower costs than ever before.
In the IT department, you're constantly presented with different issues, different requirements, different problems. And if you can turn to one vendor, one box, to give you the solution for all those different problems, that just makes your life a lot easier. And when that vendor delivers a solution at such an excellent value, then you've really hit a home run. My name is Bob Hayes. I'm the Director of Technology at ArtBeats. We do stock footage. Our business is data. Without having our stock footage online and available for the customers, we really don't have a business. So this has to be online all the time. It has to be available. It has to be up. It has to be safe and secure. To be able to just have something in place and running where it's just solid enough and reliable enough to just install and essentially walk away from for a year made things a lot easier for me. I really don't want a new hobby. I don't want to have to learn a whole lot of new techniques and procedures. I just like something that works. Installing the Nexans system in the rack is just about as simple as it can get. The unit's well designed, the hardware components are all top quality. I think it probably took me maybe about 20 minutes to put the whole thing into the rack. It's very much a fire and forget sort of a system. You set it up, you get it running, there's a quick 15 or 20 minute maybe process to configure it, and as long as you have some sort of plan in place about how you're thinking that you want to configure this box, that's it, you're done. And then it will continue to run for years after that with great reliability.
This is the Core Data Cube of knowledge. Inside this cube lies all the knowledge of data storage past, present, and possible future. Allow me to share some of our SSD knowledge with you. The interesting thing about all these new data center tools like virtual servers, VDI, and large-scale storage arrays is that they randomize your data. In the old days, you had a one-to-one relationship between a server and its storage. But now, with virtual servers, VDI, and large-scale shared storage arrays, you have a many-to-one relationship between servers, virtual or otherwise, and their storage. When you have lots of parallel read and write transactions, you randomize the storage array's activity just like a mixer randomizes your chocolate milk. SSD may be used as a way to service these random requests and optimize performance, but we don't use SSD as a dedicated fixed storage resource to do so. In these homogenized environments, it's almost impossible to know what data is hot at any given time. Instead, we use the SSD as a large adaptive read and write cache for all your data. Nexan's a good example of a company with this type of architecture. They call it the NST. The NST utilizes a scalable pool of SSD resources for caching read and write transactions. When you write data, it's written to SSD first, and then the NST system destages that new data from SSD to disk, but without slowing down your servers or the applications that run on them. And the SSD is scalable, so you can easily expand your SSD resources simply by sliding another SSD brick into a slot. In fact, the NSD performs SSD caching on both file and block-based storage, serving up data for all the storage needs of a mid-range company or business unit. There are actually several different types of SSD storage with differing choices of capacity, writeware, and cost. Non-volatile RAM, like system memory, has no wear whatsoever and offers the highest performance but at the highest cost and the lowest capacity. It's typically used for highly active small write caches. SLC SSD memory is the Cadillac of SSD bricks with the best wear and performance. It comes at a high cost, as you might imagine. eMLC SSD is the latest enhanced SSD for enterprise data storage. This is a hardened version of the economical MLC solid-state media and has become the most popular SSD for the data center with capacities that are continually increasing while costs continue to drop due to Moore's law, just like memory chips. We expect eMLC SSD storage to replace most high-performance spinning disk storage applications over the next 2 to 3 years. There's been a lot of discussion recently about tiered storage. In the simplest implementations, tiered storage is nothing more than a dedicated layer of storage media, each layer offering different levels of storage performance. If you know which data requires fast storage, you simply store it at that appropriate level. It's a decision made by the storage systems administrator. There are also recent systems offering auto-tiering features. Their software attempts to predict which data should be at which level using algorithms which monitor frequency, usage, and times of access. But these systems are either extremely expensive high-end storage solutions or they're marketing hype, less capable systems, not very effective at predicting which data will be used in random access environments, and they're not fast enough typically to really make all that work identifying and copying data between tiers worthwhile. And the storage systems, particularly the storage media, command high premium prices for all those questionable benefits. We think utilizing SSD as large-scale read and write cache is a simple, highly effective, and economical way to increase storage performance in the enterprise. And if the storage media is priced right, you can simply buy more high-performance storage to improve performance without having to predict usage patterns at all. Companies like Nexen are leading the way with systems utilizing these advanced hybrid storage architectures, offering an adaptive, expandable cache in front of your spinning disk storage array at an affordable price. So how do you implement SSD in the enterprise as a shareable resource to economically increase your overall performance? If your performance-sensitive data is easily identifiable and isolated, put it onto dedicated SSD storage media. That's like giving the express lane of this freeway a 100 mph speed limit. That makes all your express lane drivers happy. But if performance is not required for a specific identifiable group of data, and instead an overall traffic jam is the problem, then consider a hybrid storage system, utilizing SSD as a high-performance adaptive cache in front of your disk storage. That's like adding 2 more lanes to each side of this freeway. It allows you to handle more overall traffic and makes all your drivers happy. This show, Conquer Your Mountains of Data, is all about data storage and sharing our experiences serving the needs of our diverse customer base. Core Data, a data storage systems integrator located in Herndon, Virginia, has over 13 years of experience serving customers in commercial, civilian, intelligence, and military settings. We also specialize in the unique requirements of classified data, research and development, and high-performance computing environments. In affiliation with our sponsors, we hope to bring you useful analysis of the many different data storage challenges and solutions we encounter, and assist you, the IT professional, in finding new ways to solve new problems. It is our goal to help you, our viewer, conquer your mountains of data.